The topic of this video is building quadratic models from verbal descriptions, geometric models. Let's look at a problem. A rain gutter is to be made of aluminum sheets that are 12 inches wide by turning up the edges 90 degrees. See the illustration. What depth x will provide maximum cross-sectional area and hence allow the most water to flow? Alright, so I want you to imagine that this is our aluminum sheet. And we can see that our aluminum sheet is 12 inches wide. Now, this is actually not drawn to scale. This piece of cardboard is a little bit wider than 12 inches, but I think it will demonstrate the point that I'm trying to make. So, you've got this very long aluminum sheet that's 12 inches wide, and you want to get water to flow on and within that aluminum sheet. And the way you're going to do that is by bending it twice to create a U-shaped channel. So you're going to bend it here 90 degrees, and you're going to bend it here 90 degrees, and now you've got this channel that the water will flow through. And the question that we want answered is this: where do we make these bends? Now, we know that the distance across is 12 inches. So I want you to imagine that we come in 3 inches and make the bend. Well, then instead of having the full 12 inches, now there's only 9 left, 12 minus 3. And of course, if you come in 3 inches on this side, you should also come 3 inches on this side. So now we've lost another 3, so we've gone from 12 to 9 down to 6. So the base of our U-shaped channel is going to be equal to 12 minus however much we take away by bending on this side, minus however much we take away by bending on this side. Of course, this is an algebra problem. We don't know how much we should take away by bending, so that's where x gets involved. So if we take away x from this side and we take away x from this side, then we've taken away 2x. And if you start with 12 and you take away 2x, then what are you left with? This new distance across the bottom is 12 minus 2x. And that's what we see here in our diagram, 12 minus 2x. Now, if we look one more time at our channel longitudinally, like I'm looking through it, what we see is that it is actually U-shaped. It's almost like a giant staple. And x is the amount that we decided that we would allow before we made our fold line. And therefore, when we turn it up 90 degrees, the height is x on the right, the height is x on the left, and the base is the 12 minus 2x that we talked about a moment ago. Okay, so with that in mind, now we're ready to actually tackle this problem. They want us to maximize the cross-sectional area. This is the cross-section, and the area of this shape, a rectangle, is base times height. So let's write that. Area equals base times height. All right, the base in this problem is 12 minus 2x. The height in this problem is x. We'll distribute the x to get 12x minus 2x squared. And because we know they're asking us to find the most water, the maximum, we want to write this in a standard form for a quadratic, which is negative 2x squared plus 12x. Okay, so we've created a formula for the area, the cross-sectional area of our channel, based on the variable value x. Now we want to maximize it. So we recall that when you have a function that is quadratic in form and you're asked for an extreme word like minimum or maximum, you're looking for the vertex. So the part of the problem that we're going to use here is the vertex formula. Our vertex x formula is equal to opposite b over 2a. And for this particular equation, I'll change colors here for clarity. A is equal to negative 2, b is equal to positive 12, and c is equal to 0. All right, so we plug into our formula. So opposite b would be opposite 12 over 2 times a, which we'll write as 2 times negative 2. So at the top, we have negative 12. At the bottom, we have negative 4. We divide and get 3. This is the value of x that will give us the maximum cross-sectional area and hence allow the most water to flow. Now, this answers the question, what depth x will provide the maximum cross-sectional area? but we need units of measurement. We noticed that in this problem everything was being measured in inches. So therefore this has to also be measured in inches. And this is the final answer to our question. So, take your 12-inch wide piece of aluminum sheet, take 3 inches off of this side, take 3 inches off of this side, and let the water flow.